Okay, so I'm gonna go over really quick about the midterm, the practice version that I give you. So the test will look like this, and I'm gonna go straight to the point because I want to make this video as short as possible. Okay, so the first question is asking you, what is any subset of the sample space called? That's very simple. That's an event, right? Okay, an event is a subset, any subset of the sample space. Okay, what is a numerical descriptive measurement calculated from the sample called? So that's a statistic, right? I talk about if we have a population, right? The numerical characteristic of the population is the parameter, right? And if we take a sample of the population, the numerical characteristic of the sample is a statistic, right? So yeah, that's what they're asking. Number 3, which of the following represents a disadvantage of using the sample range to measure of dispersion, right? So what is a disadvantage of using the sample range? Here they said, well, they have 4 choices here. I'm gonna go straight to the answer. It should be B, the largest or smallest observation, or both, maybe outlier, right? So if you have a data set, and let's say, we know that the range is the max minus the mean, right? So the range is max minus the mean, right? However, in this, if this max is an outlier, that will affect the dispersion, right? That will deviate a lot from the results. So sometimes you have to check sometimes if these max or means are a liar. So in this case, this is the answer, right? B. Which of the following refer to the number that indicates a spread or scatter? That's measures of variability, right? The variability determines how the dispersion with respect to, let's say, the mean, let's say in this case, right? So if you think about the variability, you can think about like a target value, let's say, remember when we were talking about if we're like filling bottles of pollen spring water, let's say, right? And the, the amount of water that you need in each bottle is 500 milligrams, right? I'm sorry, 500 milliliters, right? Each bottle is supposed to have 500 milliliters, right? So that's gonna, of course, that's gonna deviate a little bit from bottle to bottle, but you're trying to minimize the variability. In this case, when they talk about spread or scatter, they're talking about measures of variability, okay? So here, consider the following data set. So you have all these numbers, so they want you to find which one is an outlier, right? You can do this by hand, you can use your calculator. If you want to use your calculator, let me show you how to do that really quick. Let me share the screen with you, and let me see if I can do that really quick. Okay, where's the calculator here? Okay. So give me 1 second. Let me share this with you. You can do this with calculator, it's easier, right? I mean, you can do this by hand, but I mean, just as practice, right? Let me open this for you. Okay, so you can just input your data, right? So here we have 2, 3, 5, 7, 8, 10, right? 12, 15, 20, and 31. I don't know why 20 didn't went through, right? 20 and 31, right? So once you do that, you check if you type everything correct. So you have 2, 3, 5, 7, 8, 10, 12, and then you have 15, 20, 31. Now that you have that, you go to stats, you go to calculation, you go to the first one, and that will tell you the 5-number summary, right? So you want to find out the outliers, basically, right? So you need the IQR, which is Q3 minus Q1, right? And Let me write this down. So here that Q3 is 15 and Q1 is 5. So that's 10. And Q1 is 5. Write that down. Q3 is 15. Right. And you can do this calculation now. Let me go back to the slide now. So if you do that, so you have Q1 is 5, 1.5, the IQR is 10, right? And then the Q3 is 15 plus 1.5, the IQR is again 10. Remember, the IQR is just Q3 minus Q1, right? The third quartile minus the first quartile, right? So let's see what we get. So this is 5 minus 15, and this is 15 plus 15, right? So if you do this, you get negative 10 and you get 30. So if you have a value below negative 10, that will be an outlier. And if you have a value above 30, that will be an outlier. And indeed, we have one, right? The 31 is above, or is out of this range, right? 31 is out of this range. So that means that that's the only outlier, right? You can do this by hand again. Let me show you how to do this by hand. If you want to do it by hand, you need to find first, you need to find Q1 and Q3, but before you find Q1 and Q3, you need to find the median, right? So since this is even, right, you can do it like this to find the median. So the median is between these two numbers, right? So the median should be, in this case, Q2 should be equal to 9. Yes. Now that you have the median, you think about you can think about what's from this part, because this data is divided in 2 sections, right? It's 2, 4, 6 numbers. Actually, let me see how many numbers: 2, 4, 6, 10, 2, 4, 6, 8, 10, right? So you can think about the half of that, right? So you can think about, yeah, from here, right? From the 9, you can think about this side, and you can think about the other side. So half of that should be between these two values, right? So if we think about, let me see how can I explain this to you. So we thought this was the median, right? So we can think about like what's half of these values, right? So that will be here, right? That would be 5 if you think about that. And if you think about in terms of the other half of the half, right? So like the half that is above and the half that is below, right? So that would be 15. Okay, so you can think about that way as well. Okay, but it's easier to do with a calculator, okay, because you will have access to the calculator. Okay, yeah, okay, so let's continue. So they say a study that involves no research intervention is called what? An experimental study, right? Because you're not doing anything. I'm sorry. A study that involves no research intervention is an observational study, right? You're not doing anything. You're just observing, right? So that's an observational study. When you don't do anything, you're just observing, right? If I want to like give you an example, like let's say a police officer is parked on the highway somewhere, and he's checking with a device which people how fast people are driving, right? If they're going beyond the speed limit or below the speed limit, right? So he's not doing anything. He's just observing and waiting for someone to go beyond the speed limit, so he will give them a ticket, right? So that's an observational study and at some degree, right? So if he just want to see how many people go beyond the speed limit, that will be he's collecting data and he's just observing. He's not doing anything, right? So that would be an observational study when there's no intervention, right? So here they have a variable that interferes with other variables in the study is called So that's a confounding variable, right? So sometimes we, like I explained to you, like if this police officer wants to see how fast people drive on a regular day, let's say, but that day he wants to see how fast people drive, like between 7 in the morning and 8 in the morning. He wants to see how people go beyond the speed limit within the time, right? Obviously, there might be some confounding variables there. Traffic might be one confounding variable, because if there's a lot of traffic, people will not drive fast, right? Or maybe that day the weather is bad, so people will not drive fast. So those are confounding variables if you're not taking that into account in your experiment, right? So a variable that interferes with other variables in this study is called a confounding variable, right? Okay. Here, which is not part of the 5-number summary. So the minimum, Q1, the median, right? Or Q2, Q3, and the max. This is the 5-number summary, right? So Q3 and Q1, that's part of the 5-number summary. The mean is not part of the 5-number summary. So that's your answer right away, right? When the distribution is bell-shaped, so basically it's a normal distribution or symmetric, right? Approximately what percentage of the data values will fall within one standard deviation? This is the empirical rule, right? This is the empirical rule. So you know that one standard deviation, right? So assuming that one standard deviation below the mean, okay, and one standard deviation above the mean. You can think about this in terms of standard deviations. Let's see, one standard deviation above. Let's use the sample. Yeah, let's use one standard deviation above and one standard deviation below. You know that this represents 68%. These will represent 2 standard deviations, right? Below and above, that represents 95%. You need to remember this, okay? 95%. This will be useful later in the next chapters. And 3 standard deviations below and 3 standard deviations above, it represents 99.7% of the values, right? So they're asking you how many if they say if the distribution is bell-shaped, what is the percentage of data values that fall within one standard deviation? You will say 68%, right? Okay. Or 0.68. The probability is 0.68, right? The number of absence per year that a worker has in an example of what type of data, right? The number of absence per year that a worker has is an example of what type of data, right? So if you remember, we have this acronym, right? NOIR, remember in the chapter 1. So NOIR stands for nominal, right? Remember, nominal, ordinal, this is interval and range, right? So if you recall, we said that these are qualitative, right? Qualitative means can be names, it can be things like remember BMW, that, or like it could be also ordinal, it could be like zip codes and things like that, right? So those are qualitative. Okay, and these are quantitative, right? But here they're not asking about that. Here they're asking you about the number of absences, right, per year that a worker has in an example of is what type of data, right? So this doesn't fit that situation, right? This is between discrete or continuous, right? So the number of absences, you can count how many days you absent in a year, right? You can say, I was absent 2 times, 3 times in year 1. In year 2, I was absent 5 days. So that's a random variable, right? So that means that change from year to year. Therefore, since you can count it, this is discrete, right? Okay. Okay, here. The number of incidents in which police were needed for a sample of 10 schools in these counties. They give you this data. Find the median, the mode, this kind of stuff. This stuff is just calculator, right? So you can find the mode, you can find it really quick. So the mode here is 3 because that's the number that appears the most, right? So the mode is 3 right away. I don't even need to check the calculator. So I need to find the mean. What else they want? Find the mean. So the mode I already did, the mean, the median. The median in your textbook, they represent as MD, right? Or MD like this. And this is Q2, you know that. The median and the variance and the standard deviation, right? Variance, standard deviation. Okay, so let's do this really quick with a calculator. Let's type these values and let's get the answer. Okay. So let me clear this up. So let's type the data. Stats here, clear this up, press clear. Okay, so just put the numbers, right? So 7, 37, 3, 8, 48, 11, 6, 0, 10, 10, and 3, right? So let's check again. So 7, 37, 3, 8, 48, 11, 6, 0, 10, 3, right? So go stats, here calculation, 1. So you have your mean there, right? 13.3. If you scroll down, remember Q2 is a median, right? Or, well, they said here median, right? So median is 7.5. The variance is, the variance of the sample should be here. So the variance here of the sample, well, they don't give you the variance, but they give you the standard deviation. So the standard deviation of the sample is, S represents sample, right? So it should be the one that says 15.9586, okay? So that's the standard deviation, 15.9586. And you need to square that, right? Because the standard deviation is the square root of the variance, right? So if you square that, you get the variance, right? Because the standard deviation is given. So if you square 15.9586, you square that, you get 254. So that's your variance, 254.6869. Since they're rounding here to 1 decimal place, you can round to 1 decimal place. So it's going to be 254.7. And the standard deviation would be, let's leave it as 15.9. Okay, or you can round it to 16 if you want 16. Okay, so let me go back to the problem, and we're almost done, right, with this test. Okay, so that's the answer, right? So that's the only thing they're asking here. So again, this is just calculator. Okay, here. So here you have an aptitude test, and the data is shown. There's 30 applicants here. Construct a stem and leaf, and leaf plot for the data, and summarize the results. So they want you to write stem and leaf. So you see all these numbers, right? First, I'm gonna write a key. So the key for my stem and leaf is gonna be, let me see, 242. So 24.2 is this. So this is my key. So the reader knows what I'm talking about. And now I need to put this in the calculator, because if I do this by hand, it's gonna take some time. So again, we go to the calculator and we input all these data values, right? So let me clear this up, and let me go to stats again. Clear this up, stats, edit. So because they're asking for a stem and leaf, I have to organize my data from lowest to highest, right, in order, right? So I'm gonna clean this up using sort. Okay, but let me input my data first, right? So this is 204, that's my first value, 256, 251, 237, 218, 260, 210, 238, 243, 247, 212, 230, 227, 242, 233, 211, 217, 228, 218, 253, 251, 222, 227, 242, 254, 227, 241, 231, 209, and 200, right? So the only thing you need to do is now you go to stats and you see where it says sort A. So you're gonna press that, that's number 2, or you just scroll down. And you're gonna put second L1, and it says done, right? So you go back to your stats and you go to edit. So now everything is in order, you see? Everything is in order. So now you can do the stem and leaf because they want you to do the stem and leaf by hand in this problem, right? So I'm gonna do that right now. So 200, let's remember what's a stem and leaf, right? Okay, so we have 200, we have 04. Okay, okay, 9, 10, okay, up to 10, to 10, 11, 12, 17, 18, 2, 22, 27, 27 again, 27 again, 28, 30, 31, 33. Actually, so 30. I will share this with you. I'm just writing, I'm doing the stem and leaf while I'm reading the calculator. 30, 31, 33, 37, 38, 41, 42, 42, 43, 47, okay, 251, 1, 3, 4, 6, 260. Okay, so I'm done, right? So let me share this with you now that I have everything now. So you're supposed to have something like this, right? So I write my key here, right? So this is my key. And that's how the people, when they're reading this stem and leaf, they know what I'm doing. My stem is here, my leaf is here, right? And that's my stem and leaf. That's what they want, right? Make a stem and leaf of the out of depth distribution. So that's my distribution. And now they're asking me to find the median, right? So the median is very easy. They want me to find the exact value, right? One of these values represents the median. So C equals MP, right, over 100. Or you can say just N times the percentile, right? So N is the sample size. So this is 30. And well, let's do it like the book said. So that's how the book said. The percentile is, the median represents the 50 percentile, right? So the median is equal to the 50th percentile, right? So that means that I need to multiply times 50 divided by 100. So this is 15 and 2 zeros, 100. This cancels out. I get 15. So C is 15. So the 15 observation is the median. So let's do that. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes? Since this data is kind of even, right? Because there's steady observations, you should say the median should be between 230 and 231. That's going to be 230.5, right? So here the answer for this one, for part A, is 230.5, right? Because there's an even, the sample size is even, right? Steady. Now, let me erase this stuff. Okay, the next question is find, so that's part A. So part B is asking you find the 40th percentile. So again, the same thing. MP, so M is a sample size 30, the 40 is a percentile divided by 100. So this is 12 and 2 zeros divided by 100 is 12, right? So the 12 observation, it means that's the number I need to write here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 227 is the 40th percentile, right? Here the part C, they're asking you the 70th percentile. So again, the same thing, 30 sample size times 70 divided by 100. So this is 21 and 2 zeros divided by 100, you get 21. Yes, so C is 21. So the 21 observation is the thing I need, or what they're asking, right? So let me erase this stuff. So instead of counting from the beginning, I'm going to count from the end, right? Because I know this is 30, 30, 29, 28, 27, 26, 25, 24, 23. So it's supposed to be 243, right? This is 243, right? The last one is 30, 29, 28, 27, 26, 25, 24, 23. Actually, they said 21, right? I'm sorry. 22, 21. So it should be 242, sorry. All right? Because it's supposed to be 21. So again, 30, 29, 28, 27, 26, 25, 24, 23, 22, 21. So 21 is 242. Now this one I made a typo here. It's supposed to be 243. So they say find the percentile corresponding to the score of 243. So now I have to do something else, right? This time the percentile, asking, right, is the number of values below 243, right? Plus 0.5. And this divided by 100, right? I'm sorry, no, by 100, by the sample size, sorry. So here, what is the number of values below 243? You need to count again, right? So below 243, you can use your, you can just count, right? Or you can just subtract or whatever is easier for you. Okay, so here 243 is here. So what values are below 243? You can just count, right? So since there's steady values, right? So here we have 2, 4, 5, 6. There's 7 values above 243. So they're supposed to be 22 values below that, right? So let's see. You can count it. If you don't believe me, you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, right? You can just calculate it out mentally, right? But I'm just doing it just in case you don't get it. So there's 22 values plus 0.5. The sample size is 30. So this is 22. I'm sorry, and then you need to multiply by 100, right? So this is 22. Let me make this clear so you don't get confused. So this is 100 here. So this is 22.5 divided by 30, right? And times 100. So you use your calculator, right? Whatever that is. 22.5 divided by 30, and you multiply that times 100, and you get the 75 percentile, right? Or you can say 75. Well, let's say because they're asking for the percentile. So this is a 75 percentile, right? So 243 represents a 75 percentile in this data set. Okay, so these formulas, they're from your slides. Okay, this is from your slide. Okay, this is not if you go back to your slide, chapter 3, you will see these formulas. Okay, I'm just solving the problems now. Okay, let's continue. So here we have some calculation again, right? Let me go over this one more time with you. Okay, I'm gonna stop here and I'm gonna record another video, because otherwise the video is gonna be too long. So in the next video, which is gonna be as soon as possible, I'm gonna do question 4, question 5, and question 6, and 7 is multiple choice, so that should be quick. Okay, so because if I do this, it's gonna take so long. It's gonna be so long, and then it's gonna take time to upload or download it or whatever. Okay, give me maybe like 30 minutes. I will put the second part. Thank you.